Welcome to today's Explainer, where we are going to completely transform how you think about code architecture. Today, we're unpacking the actionable habits that prioritize long-term maintainability over those quick and dirty fixes we're all guilty of. So if you want to write code that actually scales and endures, you are absolutely in the right place. Let's jump right in.
Let's start with a painfully relatable question. Have you ever stared at a totally tangled web of logic, cursed the developer who wrote it, checked the version control, and realized the culprit was actually you? Yeah, we've all been there. It's a pretty humbling experience, isn't it? But honestly, it perfectly highlights exactly why writing for future you is our ultimate goal today. Long-term readability is everything.
So here is our roadmap for mastering system design today. First, we'll tackle the technical debt trap. Second, writing for future you. Third, thinking in systems, not syntax. Fourth, core clean design principles. And finally, we'll wrap up with the Boy Scout rule.
All right, Section 1, the technical debt trap.
Back in 1992, Ward Cunningham coined a brilliant metaphor for this. He said, taking early shortcuts in your code is literally like taking out a financial loan to get a product out the door. Initially, you speed up, right? You get that immediate boost. But ultimately, those shortcuts completely destroy your responsiveness to change down the line. Every single minute you spend working around not quite right code counts as interest on that debt. And eventually, the cost of making even a tiny change just skyrockets.
That brings us to Section 2, Write for Future You, where we focus on long-term readability.
Look, prioritizing clear, predictable code over clever shortcuts is absolutely crucial. Writing super dense, clever code might feel really impressive in the moment, but it almost always loses its expressiveness and creates massive confusion later on. You really want to follow the leave no questions rule. Why? Because our memory fades rapidly, but good documentation, meaningful comments, and intuitive variable names, those stick around forever. Moving right along to Section 3, Think Systems, Not Syntax. This is all about developing a senior mindset. There is a stark contrast in focus when you make this leap. While junior developers tend to focus heavily on executing language syntax and just getting today's feature done, seniors naturally zoom out. They frame the problem first. They ask things like, wait, do we even need this feature? Or is there a simpler way to solve this? They are constantly ensuring that the overall system is going to scale for tomorrow. Ultimately, this transition is about moving from dependency to autonomy. A senior developer isn't just a machine that writes flawless code. Actually, scratch that. They are someone whose soft skills, long-term thinking, and system mastery become their primary tools. They work independently, they make the critical design calls, and they actively mentor others around them. Let's dive into Section 4, Core Clean Design Principles, building on that solid foundation.
We have to start with our first architectural guardrail, SRP, the Single Responsibility Principle. This principle is what prevents those terrifying tangled God classes from forming. It ensures every single module has one clear, distinct purpose. Basically, it should answer to only one business rule or external system. To put that into practice, you need to watch out for files that mix database access with business logic. For example, if you have a file handling HTTP logic, running the billing, and firing off email notifications, that's a huge red flag. You should always extract those secondary responsibilities into their own isolated classes. That way, if you need to swap out your email provider, you can do it without ever touching or risking your core billing logic. It's a real game changer for stability.
Next up is the Open/Close Principle, or OCP. Think of this as a protective shield for your shipped production code. It protects your working systems from regressions when you're adding brand new features. The golden rule here is extend behavior, do not modify working code.
By leveraging design patterns like the strategy pattern, you add new behavior completely alongside the old stuff. So if you need a new discount pricing tier, you definitely don't hack into a massive, brittle switch statement that's already running smoothly in production. No way. You just create a new class. This keeps your feature branches incredibly small and makes merge conflicts super rare.
All right, our final stop, Section 5, the Boy Scout rule and the power of micro-refactoring.
So how do we actually maintain these pristine architectures without grinding our sprints to a halt with massive refactoring projects? Well, always leave the campground cleaner than you found it. Adopting this rule is arguably the most underrated practice in software engineering. It means making a deliberate micro-improvement every single time you touch a file. By doing this, you reverse codebase entropy at the exact same rate it naturally accumulates. But to keep this sustainable and safe, you absolutely must follow some strict rules of engagement. Number 1, keep it under 5 minutes. If it takes any longer, it's a full-blown task, not a micro-refactor. Number 2, never ever mix behavior changes with cleanups, keep them in separate commits. And number 3, always run the tests to verify. Ensuring your cleanups are obvious and completely isolated is key here.
Let's summarize your daily toolkit with a few highly actionable habits that will quietly compound over time. First, use explanatory variables. They instantly name the steps in a complex algorithm, making it readable at a glance. Second, maintain a debug journal. Typing out your thoughts slows down your reasoning and creates a kind of private rubber duck that helps you catch those tricky edge cases. And finally, make it a solid habit to start your day with PR reviews. This unblocks your peers and gets fresh code out to production fast.
I want to leave you with one final challenge today. Transforming from a junior code writer to a true senior system thinker starts with the exact intention behind the very next line you write. So in your next commit, will you just be adding code, or will you be actively improving the system? Keep that in the back of your mind the next time you fire up your editor. Thanks for joining me on this explainer, and happy coding!